Good morning, everybody. This is part of a series that I call Exploring the Solar System, and this little short talk is on robots on Mars. Hopefully we'll have enough time at the end for a few questions, and I invite you down to have a closer look at how Earth and Mars orbit the Sun, which is of course important when we're thinking about how to get spacecraft to Mars. So I'll be saying a little bit about Mars and Martians, and then thinking about what has there been in terms of landers and rovers, asking the question, in a sense, why are they there and what have they found? And then at the very end, what's the next step going to be beyond what we've got at the moment? We've, of course, always had a fascination with Mars. Mankind has always been interested in the red planet. And this was came to fever pitch a little while ago when H.G. Wells wrote War of the Worlds and described how Martians would be invading the Earth. So we had the book, we had the radio broadcast, we had the film, and ultimately we had the musical as well. But perhaps when people think about Martian, you don't necessarily think of War of the Worlds. Perhaps you're more likely to think of Matt Damon as the Martian being stranded on the red planet. But we should just take a second to just remind ourselves not to take this for granted. This is absolutely amazing. 100,000 years ago, some humans were still living in caves. And yet now it is possible for mankind to build machines, put them on top of rockets, send them to another planet, land them safely, have them wander around, and send back high-resolution images like this. The fact that we can do that is amazing technology that's been developed in the last few decades. So we can imagine what the next few decades are going to be like. The surface of Mars looks a bit arid. It looks like deserts on Earth, some of the deserts on Earth. So you might say, this looks a bit boring. It's very dry. There's no life there. I can't see any trees. I can't see any animals. But the rovers have found evidence that water, running water, standing water, did exist. There have been rivers. There have been lakes. They don't appear to be on the surface now. But if water did exist on Mars, and we think life existed on Earth because of the oceans, that's where life started, and then life came out onto land. If there has been water on Mars, maybe life has developed on Mars. It is even possible that the life is still there. We can't see any water, but maybe the water is below the surface. That's definitely worth investigating. So I'm not going to describe the entire history of the exploration of Mars. We just don't have enough time for that. Let me run through some of the American landers and rovers. There have been other nations. China currently have a rover on Mars, for instance. But it's just simply easier to get all of the information from the NASA web pages where they document everything that they have done. It started in 1976 with the Viking lander. Since then, there have been a number of different landers and rovers. I'll be saying a little bit about the two small rovers, Spirit and Opportunity, that were there in 2004. And there have since been others. NASA produced another fairly large rover called Curiosity and a very similar cousin to that called Perseverance. So again, it's not worth talking about all of the individual missions, though they are very interesting in their own right. I'll just say something about those that are highlighted there in red. But my first memories of Mars were back in 1976 when I remember, no, we didn't send Carl Sagan to Mars. This is Carl Sagan standing next to a model of the Viking lander out in an Earth desert. It gives you a sense of scale. Size of a small car, that sort of thing. But I do remember when the news came back that the Viking lander had successfully landed on the surface of Mars, and on my TV I saw pictures of the red planet. I thought that was absolutely amazing. Yes, it's incredible that we've sent astronauts to the moon in the late 60s, early 70s, but I thought it was absolutely amazing on my TV to be able to see color images taken on another planet. And that, amongst other things, got me really interested in astronomy and space flight and exploring the solar system and ultimately exploring the universe. How do we get a rocket to the surface of Mars? It's actually a relatively small rocket that's needed compared to the absolutely huge rocket that we would use to get to the moon. The Saturn V was 3,000 tons of rocket in order to get men to the moon. By comparison, the rockets that send landers and rovers to Mars are much, much smaller. But Mars is, of course, much further away than the moon. So why is it that you can get away with a smaller rocket to go to Mars, but you need an absolutely humongous rocket to get to the moon? It's not about distance. Distance is almost irrelevant. What matters is how much mass do you want to lift off the surface of the Earth and get into orbit and ultimately move fast enough to reach escape velocity so you can leave the Earth and then go on your way. Once you're on your way, it really doesn't matter whether you're going to the moon or whether you're going to Mars. What matters is the mass you want to send. In the case of Apollo, the Saturn V had to lift more than 100 tons off the surface of the Earth in order to get Apollo astronauts on their way. But a lander or a rover might only have a mass of maybe 1 or 2 tons. Much smaller, much easier to get there. So what do you do when you get there? Here's a little animation of what happened for Spirit and Opportunity are effectively the same, sent to different parts of Mars. When you reach the atmosphere is thin, but still slows you down. Aerobraking, it's called. Gets hot, so you need a heat shield. But eventually you're slowing enough that you can start to deploy a parachute. You're still going really fast at this point. You're still going faster than sound. It's a supersonic parachute that will slow you down still further. Eventually you're slow enough that you can get rid of the heat shield, and the lunar rover is inside that little pyramid structure. We want to get that onto the surface of Mars. It's not that massive, but how are we going to do it? We want to minimize the technology. Airbags are the simplest way of doing it. If it doesn't weigh more than a few hundred kilograms, you simply get close to the surface. You don't worry about accuracy. You don't worry about precision. You don't worry about crosswinds. You get close, you deploy the airbags, and you drop it, and you let it bounce. And bounce. And bounce. Of course, you've got to make sure that your rover in the middle of that airbag system is very securely tied down, but basically you just let it go. And eventually, after 20 to 30 bounces, eventually it comes to rest. As long as your rover can take those G-forces, everything should be fine. You deflate the airbags, and then you start to unwrap yourself. A very clever design because it's a pyramid. As soon as it starts to unfold, it automatically rights itself. So there's the rover sitting in the middle of its little triangular platform. Once it's on the surface, one of the first things it does is start to unfold its solar panels so it can start to get power to make sure its batteries are charged. So there are the solar panels undoing themselves, like a little dainty butterfly. There's a camera on top of this white mast, which has been folded down for flight to Mars. It's now going to put itself into the upright position, and just behind it, what looks like a little table tennis bat, that's a little antenna that it's going to use for radio communication between the rover and a satellite in orbit, and ultimately relaying messages back to Earth. So it's got a stereo camera up here. It can look around. It can make sure it's definitely the right way up. It can tell mission control, yep, I'm down on the surface, I'm the right way up. What do you want me to do now? And then mission control will say, okay, go roving. Lift yourself up and unpack your wheels. The wheels have been tucked underneath to save space. Now the wheels are going to be deployed. Most rovers have 6 wheels to make sure that if one breaks, it can still move. It's now going to trundle off the platform, but it needs to look at what's going on. It uses its stereo camera to look at the rocks. It doesn't necessarily make decisions for itself. It asks mission control, what should I do about that rock? Should I go over it, or should I stop and turn and avoid that rock? Virtually all the commands of these early rovers came from mission control back on Earth. The design specification of these early rovers was, let's hope they last for at least 3 months, preferably 6 months or maybe even longer. So it went off to explore the planet. What is it that ultimately dictates the life of any rover? Well, if we have a look at those solar panels that provide the power, the camera on the top of the mast can be told to look downwards so that we get effectively a selfie. So this is a selfie of the rover, and we're seeing the solar panels here, which appear to be reasonably clean. There's the red dust of the Martian surface in the background, with a few tire tracks in the background there as well. But sooner or later, things get rather dusty on Mars because the soil, the dust, the sand is very fine. And although Mars doesn't have much of an atmosphere, the dust does tend to get kicked up. And sometimes the dust settles on the solar panels. And a few months after use, instead of getting a selfie that looks like that, the selfie is more like that. In other words, you can hardly see the solar panels because they're covered with the same red dust as the red dust in the background. And when you start to cover solar panels, of course, you lose efficiency. You're not going to get as much power when the sun is on those solar panels. And you do really need power, not just for locomotion, you also need power to stay warm. If we think about the Mars environment, Mars is about half the size of the Earth. The tilt of the spin axis is very similar to Earth, 23.5 degrees for Earth, 25 degrees for Mars. And the length of time they take to rotate is very similar. Earth rotates once in slightly less than 24 hours. Mars takes a little bit more than 24 hours. So the day-night cycles of Mars and Earth are very similar, and the seasonal cycles, which are determined by the tilt of the spin axis, those are very similar as well. The big difference is that Earth has a thick atmosphere and Mars has a very thin atmosphere. If you think about on Earth, we get sunlight during the day. Well, most days we do. We get sunlight during the day, keeps us warm. At night, the temperature might fall, but not by much, because we have an insulating atmosphere keeping us warm. The Earth has a duvet, which means the day-night temperatures don't vary that much. But rovers have to keep warm at night, and the day-night temperatures on Mars can differ considerably. During the summer, the day temperatures can be above freezing, could even be as high as 10 or 20 Celsius, but the nighttime temperatures will plummet because there's no atmosphere to keep the heat in once the sun is no longer shining on the surface. And rovers cannot stand to get cold. Basically, you have to keep those rovers warm, preferably somewhere above freezing is ideal, and you can't let them go to -100. They are made of mechanical and electronic subsystems, and if they freeze, they die. So it is absolutely imperative that the solar panels work to charge the batteries so that during the night they can run heaters to keep the rovers warm. And that ultimately is what kills these design of rovers. Opportunity, just like Spirit, designed to last maybe 3 months, maybe a little bit more. Spirit actually lasted for quite a few years. Opportunity didn't actually die until 2018. It was, remember, on the surface in 2004. So designed for 3 months or more, it actually lasted over 14 years roaming over the surface. What ultimately got it was the fact that it encountered a dust storm one winter. The dust storm was so severe, there was so much dust in the atmosphere, the sun was completely blotted out. So during the day, it could not get any solar power, it could not charge its batteries, and so it knew that it was going into the night with no power and it would not be able to keep warm. So in 2018, the last transmission we had from Opportunity was battery low, getting dark, and that is the last we heard from Opportunity. It must have died that winter's night, and it could never be revived. NASA said, okay, solar panels are great, but they have this problem with getting covered in dust, and we haven't found a good solution to keep the solar panels clean. In future missions, we want to take bigger rovers to do more things with more scientific equipment. We need another power source. And they decided for two of their rovers, Curiosity and Perseverance, we're going to use thermoelectric generators that don't rely on the power of the sun, and they last an awful long time. They've been used by some space missions to explore Jupiter, Saturn, Uranus, Neptune, etc. They have a finite number of these power systems, so they can't use it on every mission, but they decided for the next two rovers, which are going to be big, they're going to be over a ton each, compared to the rather smaller Spirit and Opportunity, and they've decided to use these particular generators. Getting to Mars and landing on Mars is similar, at least to start with. You aerobrake and then you have parachutes, but getting a much bigger rover on the surface takes a little bit of thought as to how you're going to do it. So let's see how Perseverance landed. Same rocket gets you there effectively, and again you aerobrake through the atmosphere. Gets hot on the outside, but there's Perseverance on the inside, getting shaken up a little bit, but otherwise it's okay. Again, this does a little bit of steering to try and find where it's supposed to be going. Once it's going slow enough, it deploys a parachute, just like in the earlier rovers we saw. The parachute eventually slows it down to the point where we can ditch the heat shield, and then Perseverance is dropped. And there are some retros to slow it down, retro rockets, but you can't land with those because they would kick up so much dust, the rover would be covered in dust even before it started its mission. So you can't get the rockets too close to the surface, so how do you land a really heavy rover? Airbags won't cut it for this particular mission. They steered where they wanted to be, downward-looking cameras told it where it was, then it went into a hover, and it winched Perseverance down to the surface on cables, then guillotined the cables, and the crane flies off and crashes safely some distance away. There's the generator on the back end of Perseverance. Notice no solar panels in sight. It doesn't need any, it's got all of the power it needs. And this particular animation, this long, slow pullback, is a reminder that even though we've got a few rovers on Mars, and even though there have been a few rovers on Mars, Mars is half the size of the Earth, but that is still a huge surface area. Rovers can't rove that far. There's a misconception that they go trundling at great speed. No, they move very slowly. They explore over kilometers or tens of kilometers. But of course, that is only a tiny fraction of the whole planet. So it's very important that when you decide to send a lander or a rover, you choose very carefully where you want to send it. We want to send it here because it looks like a river might have flowed here. Let's go there and examine the rocks very carefully. So here's a selfie of Perseverance, or Percy to his friends, and its little helicopter Ingenuity, or Ginny. How do you get a selfie like that? Because there's obviously nothing else around to take the picture. For us, a selfie means take out your phone, hold it up, smile, click, done. It's a little more complicated to take a selfie with a robot on Mars, but as well as having a camera on this mast that you can see here, there's also a camera on the arm you can't see. There's a camera on the arm that is used as a robot arm for taking samples, drilling into rocks, doing that sort of thing. And when that camera is lifted up into the air, it can take a whole set of small images which eventually get mosaicked together into the final selfie. There's the robot arm, and it moves in such a way that the lens stays still, even though the camera moves backwards and forwards to take lots of images, which then get stitched together to give us the final result. And the robot arm itself is effectively not included in the picture. So it looks like the camera is just sort of floating above the rover, but it is perfectly genuine selfie. You can see the rover itself. It's looking like a nervous parent, just checking that Ingenuity is okay, like a little toddler down there, and it hasn't run off. How did they get Ingenuity there? Well, it was on board on the underbelly of Perseverance. So it came down under there, and once it was landed and once it was safe, the helicopter was taken off the belly. It was then placed on the ground. Once it was safely on the ground, Perseverance rolled away so that the helicopter could then do its test flying. The idea of taking a helicopter is, this is a prototype. Can we fly on another planet? There was no point in trying on the moon where there's no atmosphere, but now we have an atmosphere. It's thin, so we need big helicopter blades spinning quite fast, but now we can fly. Why might we want to fly? Well, rovers travel quite slowly. A helicopter can travel more quickly, and it can fly at altitude and scout out where the rover wants to go. So it can be a very useful aid to a rover. Here is Perseverance imaging and recording the sound of Ingenuity flying. The sound, a bit of wind noise, and perhaps you can hear a hum. That hum is the sound of the rotor blades recorded by Perseverance. So you're listening to a spacecraft flying on another world. This is the first time that's happened. As a prototype, it was literally, can we do this? Will it actually work? With such a thin atmosphere, can we get a helicopter to work? Now they've established it does work. NASA have plans of sending helicopters to worlds with much thicker atmospheres. For instance, the moon of Saturn, called Titan, has a very thick atmosphere that we can't see through, and it would be great to send a helicopter with a thick atmosphere. We can carry a much heavier load, so we can have not just a camera, we can have loads of scientific equipment and go explore the world of Titan. From outside the atmosphere, we really can't see what this world looks like. We did send a probe in, just literally something that fell on a parachute to the surface to give us an idea of what the world looks like. It turns out it's a world with mountains and lakes and clouds and rain. Unlike the moon, it seems to be a very dynamic environment. And so we have a good reason to want to go explore this moon more. And it might well be that the next thing to go to Titan will not be a rover, but it will be a helicopter. Any of the NASA missions that have happened in the last few years, NASA have tried to get the buy-in, as it were, the engagement of everybody, whether they be adults, whether they be youngsters. And one way of getting people interested in the missions is to say, if you wish, you can have a boarding pass. It's free, you just ask and they'll give you a boarding pass. And what they do with all of these boarding passes, I asked for this one in about 2018 for the Mars 2020 mission, in other words, Perseverance, that went a year or two after I got the boarding pass. The boarding passes were then put into a chip which is on the back of this bracket. Where is that bracket? That bracket is on the back end of Perseverance. So I know that my name is on the Perseverance rover. So I have this engagement whereby whenever I see Perseverance has now imaged this or discovered that, I know that I am going with it in sort of metaphorical sense. And this is something they're doing for lots of missions. If you want to go to Jupiter, you can do that. You can sign up for your name to be sent to whatever the next mission they have in mind is. I guess at some point they'll be asking for who wants to be on board the Dragonfly helicopter sent to the moon of Saturn. It's only a question of going to the NASA web pages and finding the relevant site. So why do we explore Mars? Well, there's lots of reasons why we might want to explore Mars. One of the reasons is to study its geology and climate. So geology isn't quite the right word because geo means earth, but I think you know what I mean. If you want to study the rocks and how they're put together, and you want to understand the interaction between the planet and the atmosphere, well, one of the reasons that we want to study Mars in detail is not simply because we want to interest in necessarily is life there or not, because we think that what has happened to Mars in the past might be something similar to what's going to happen to Earth in the future. A long time ago, Mars lost its magnetic field, and because it's lost its magnetic field, it lost its protection from radiation, and that stripped away its atmosphere. In the far distant future, the Earth is going to lose its magnetic field, and it might be that we lose our atmosphere as well. So what has happened to Mars might happen to the Earth in the future. So the more we study other planets, the climate, the geology, how the rocks are put together, the whole interaction of the entire world will help us when it comes to trying to understand the geology of our planet and how everything interacts between the crust of the Earth, the atmosphere of the Earth, the oceans of the Earth, etc. And some people say, well, we really want to send rovers to Mars because ultimately we want to prepare for human exploration. The timescales for that are very unclear. We know that at the moment we can send some rather sophisticated robots to Mars and indeed other planets. How long it will be before we're ready for human exploration of Mars, that is by no means obvious. It'll be expensive, it'll be complicated, it'll be dangerous, it's going to be a long mission. It only takes a couple of weeks to go to the moon and back, but it takes a couple of years to go to Mars and back. So it's an altogether different technological challenge. But what we would really like to do is, because Perseverance is gathering samples and trying to analyze as best it can as it goes along, there's a limit to how much instrumentation we can put onto a rover, even a relatively sophisticated one. It's only 1 or 2 tons of instrument, and a lot of it is dedicated to just moving around. So we can put a little laboratory on board, but we'd really like to analyze these samples that it's been taking, rock samples, atmosphere samples. We'd really like to get those back to Earth so we can examine them in the laboratories we have on Earth, which are, of course, much more sophisticated than the ones that are actually on the rovers themselves. So Perseverance has been collecting samples. Some of them it's been leaving behind as a sort of breadcrumb trail as it goes along. Some of them it's keeping on board. But how are we going to get them back to Earth? One plan is to send Perseverance a companion, a lander, not a rover, a lander that will come down. Perseverance will trundle over to the lander, and Perseverance will take all of its samples and transfer them one by one from its own store into the store on the lander. Something like 24 perhaps, or thereabouts. Samples of rock, samples of atmosphere. Then they'll be sealed up. That lander is too heavy to get off the ground again, but inside it has a little rocket, and that is where the samples have been placed. So that rocket can then be launched, and there's Perseverance watching it go. That can be launched back into Mars orbit, where it will meet up with another orbiting satellite, and finally those samples will ultimately be returned to Earth. The so-called Mars Sample Return Mission. It was decided a long time ago they would send Perseverance to collect the samples before they had figured out how they're going to get them back to Earth. So in other words, let's get the rover up there looking, and then we'll figure out the Mars sample return. So NASA and ESA, the American and the European space agencies, said that's one way we could do it, the way I've just shown. Unfortunately, a certain president has decided that NASA will not pay for this. They've decided to reallocate funds. ESA, unfortunately, do not have the money to do this. So at the moment, we don't know how to get those samples back from the surface of Mars. It is going to happen sooner or later. The samples are perfectly safe, but it doesn't look like they'll be coming back in the next year or two, and we're not too sure. Maybe we find different funds to do what I've just shown you. Maybe we have to find a cheaper way of doing it to bring those samples back. We do want to bring the samples back to have a much closer analytical look at what Mars is made of, to give us more clues about the rocks, about the climate, about the possibility of life. The next step, we know that there have been lots of American rovers. We know there's also a Chinese rover on the moon. The next step is that ESA has decided to get in on the act. Yes, the Europeans are going to have a rover on Mars. It's a little smaller than the American ones. We've gone back to solar panels because they're easier and cheaper. So it will have a finite life, but there's a very particular reason for building this rover called the Rosalind Franklin, which hopefully will go up in something like 2028. That's only a couple of years away, of course. This rover is different from any other rover because of this black box that's sitting on the front. This black box is a drill, and it is going to drill down up to 2 meters below the surface, because we know water has existed on Mars. There are signs that there's water there. There is water in the atmosphere. There's water in the ice caps. Is there liquid water under the surface? This hopefully will answer the question. If there is liquid water, we think it won't be very deep. Hopefully 2 meters is enough to find it. If Rosalind Franklin finds liquid water, that will be a game changer, because if we know there is water on Mars, and there has been water on Mars for millions of years, there is every possibility that life has developed there, and ultimately we will look for that. This rover is being built in various places, but a lot of it is being put together by Airbus UK. There is going to be a Union flag on the Mars before too long. So here are the engineers in the UK putting it together. I think somebody should tell them there's a wheel missing at the back there and has been replaced with a shopping bag. Perhaps they know that, they're still working on it. But yes, it's almost ready. Okay, yeah, give us them a wave. Yeah, right. So they've almost finished this. It will be ready to go. Hopefully it will go in 2028 and we will have a UK and a European rover on Mars. If I've piqued your interest, you can find far more information on the web pages of the various national space agencies from America, from Europe, from China. I also have some handouts that if anybody wants to have a look at them, I will also make these handouts available via PDFs, and I'll also make a recording of this talk available to you in due course. Happy to take questions. Thank you.